Okay, now we're going to look at some tangent theorems. I said 2, but I think there's 3 left. Okay, some tangent theorems. The first one is that a radius is perpendicular to a tangent. Okay, so if I draw a radius on a tangent, that radius will be perpendicular. Okay, and this is really an odd proof in the sense that you don't have another proof like that that's similar in high school. Well, among the proofs that you need to know. We prove this using a contradiction. So I'm just going to number this O, A, B, C. Okay, and we need to prove that OC is perpendicular to AB. Okay, and we prove this using what is called proving by contradiction. And what we mean by that is that we are going to assume that this is not true. We have to prove this, but we're going to start assuming that it's not true. Assume that OC is not perpendicular to AB. Now, what we're going to do is say, okay, well, let's now assume, or let's then construct the line that is perpendicular. So our construction is going to be construct OD so that OD is perpendicular to AB. Okay. Now, I know, guys, this is not going to look perpendicular. The idea is not that it is perpendicular. Okay. So here's OD, and we're going to say OD is perpendicular. We know it's not because we know this one is actually perpendicular. So, and there's only one perpendicular that we can draw. So we have to now imagine that one is perpendicular. Okay, and we're going to make another construction. Construct E on DB. So I'm on DB. I'm going to construct another point E so that CD would be equal to this ED. So I'm going to construct another point here. This is going to be the point E, and I'm going to construct it so that this line here, CD, is going to be the same length as DE. And now what I'm going to do is I'm going to show that triangle OCD is congruent to triangle ODE. Do they look congruent? Does OCD and DOE, do they at all look congruent? It should actually be the other way around. Sorry, it's not ODE, it's OCD and OED. They are not congruent, but that's because we're assuming something that's false. None of the rest looks right, but we want to continue this until we find a contradiction, not in the picture, but an actual real contradiction. Okay, now I'm going to show that there are, if these if it is true that this angle is a 90-degree angle, then they must be congruent. Okay, so we see that we are going to show that angle ODC is equal to angle ODE is equal to 90 degrees. Okay, and it's equal to 90 degrees because we constructed it like that. It definitely doesn't look like it, but we are going to assume it is. The second part, now you can see I'm doing the right angle hypotenuse side. So that no, I'm not doing that. I'm sorry, I'm not doing that. Okay, I'm doing side angle side. Okay, because I know CD, I know these two, and I know that one. So I know the side, and the interior angle. Okay, so now my other side is that CD is equal to DE, and again it's true because I constructed it. And then thirdly, OD is equal to OD, that's a common side. Therefore, I can now assume, that triangle OCD is congruent to triangle OED. Okay, so this triangle and that triangle is congruent. That means all of these sides have equal lengths. Okay, which means that side OC must be equal to side OE. Look here, from here, OC, the first two must be equal to the first two there. Therefore, OC is equal to OE. Okay, from congruence. Okay, but OC is a radius from the center. That means OE must also be a radius from the center. Make sense? So OE is also a radius. But if OC is a radius, it's because O is the center and C is on the circumference. Make sense? And then if this one is also a radius, it must mean that O is at the center and E must be on the radius. Okay, therefore, on the circumference. E is on the circumference. So if I wanted to draw this picture, E is supposed to be on the circumference. In other words, the line is supposed to look like this. This is what AB is supposed to look like if what I've been doing is correct. Okay, but E is not on the circumference, or AB can't look like this because AB is a tangent. That was given. A tangent means I only have one point on the circumference. I'm a line that touches the circle but with one point. Okay, so now you can say, but that is a contradiction. That is a contradiction since AB is a tangent and the only point on the circumference, is at C. And if we get to a contradiction, we have to realize that the reason why we get this contradiction is because we assumed something that was wrong. So now we can reject our assumption. This is wrong, and we assumed it is not perpendicular. So the opposite of that is, it is a perpendicular. So since we get a contradiction, therefore a OC is perpendicular to AB. Okay.